Alrighty, we're going to find the limit as x approaches 4 of this function. First thing you do, like always, is you plug in 4. So let's see what happens when you plug in 4. Okay, 4 minus 4 over the square root of 4 minus 3 minus 1. What do we get here? That we get is 0 over the square root of 1 minus 1, which is 0 over 0. So, okay, I need another method. This is not going to work. So, okay, let's think factor. Okay, I can't factor this. That's not going to work. Okay, so what do we do now? Okay, there's another method. What we're going to do is multiply top and bottom by the conjugate. So, here we go. I'm going to multiply top and bottom by the conjugate of the square rooty part, the one that has a square root in it. So I'm going to multiply the top by the... All right, let me do a little bit of erasing here. So let's erase this to get some space. All right, so the bottom conjugate would be the square root of x minus 3 plus 1. We're taking the conjugate of the bottom, and we're going to multiply top and bottom by that conjugate of the square root related piece. All right, so it's different. You're not just factoring, you're doing this multiply top and bottom by something, and the conjugate is your thing. You know when to do this conjugate thing is basically when you have a square root plus something in a numerator or a denominator. That's when you kind of know that's the path you're going. All right, so watch what happens when you clean this all up. All right. By the way, with limits, you always want to write the limit as x approaches 4 every time until you plug numbers in. It's just important to keep it there. The top, I'm going to ignore for a second. The bottom is FOIL. When you multiply those two pieces, you simply get x minus 3. When you multiply this times this, you get x minus 3. When you multiply this times this, and this times this, don't they cancel? And then when you multiply negative 1 times 1, you get minus 1. See how the bottom square roots disappear? Now, I might have lost you there for a second, but again, when you multiply this times 1 and negative 1 times this, they undo each other. Do you guys remember difference of squares? Isn't this really a difference of squares where the middle disappears? So the middle basically disappears when you do a conjugate, and you're left with the front and the back. Nice and clean. And we're just going to leave the top for now. You'll see why. But the top is going to be x minus 4, and we leave the square root of x minus 3 plus 1. All right. Now, let's rewrite this. I have the limit as x approaches 4. The top is still x minus 4. And we have the square root of x minus 3 plus 1. And if you clean up the bottom, don't you have x minus 4? See, when you clean up the bottom, don't you have x minus 4? Now, do you see why I told you to keep the top as is? Do you see a cancellation? Oh, nice. Your goal is to make so you can cancel something, so you can eliminate something. So those go bye-bye. Bye-bye. And then you go limit as x approaches 4 of the square root of x minus 3 plus 1. So now can you plug in 4 in your new function? Again, this function is almost identical to this, except it filled in a hole. All right? That's what we're doing, trying to fill in the holes where there's these holes in the graph. Okay, so what we now do is plug in 4. So if we plug in 4, what we have here is we have 4 minus 3 plus 1. And by the way, when you plug the number in, you don't have to write limit anymore. The moment you plug in, you have to write limit until you plug the number in. Kind of like remind you, hey, don't forget about me. Don't forget to plug me in. Okay, so that becomes the square root of 1 plus 1. And the square root of 1 is 1, so 1 plus 1 is 2. So our answer to this limit problem is 2.